This week's episode is brought to you by 99 Designs. Selection, speed, and creativity are just a few of the benefits of having several designers work on your project. Start your next design project at 99designs.com/smart and get a $99 power pack of services free.
A podcast where we talk to smart people, but not necessarily done by smart people.
That is an awesome question.
This one goes down probably on one of my top 5.
Hey, I like nutrition. I like to eat food.
This is the coolest thing ever. We're going to do this forever.
I wish I paid more attention in that class.
You know, I'm going to be honest, I don't understand that. As a man, I don't get it.
Welcome to smartpeoplepodcast.com.
Hello and welcome to Smart People Podcast, conversations that satisfy your curious mind. I'm Chris Stemp. I got John here with me, and we are happy to bring you this week's episode. You know what's so cool about the show in general is we get to do episodes like this one, and it's kind of bizarre. It's not necessarily a topic that's in the news, and it's not necessarily a book you would have read or a guy you would have heard of. But the thing is, when you think about this topic, your mind gets blown for a little bit. At least mine did. This week, we're interviewing Alan de Queiroz, and he wrote a book called The Monkeys Voyage: How Improbable Journeys Shaped the History of Life. Now, The Monkeys Voyage jumped out to me because, as you know, our mascot is the monkey. Our logo is the monkey. Speaking of which, we have monkey stickers in. So if you would like a sticker, the really cool laptop stickers, there's pictures of them on our social media, tweet at us. We are at Smart People Pod, and let us know you want one. We'll send you a few if you want to give them out to friends, put them on your laptop, show the world that you enjoy the show. So anyways, back to our guest this week. Alan is an evolutionary biologist and adjunct faculty at the University of Nevada, Reno. He's written widely cited research articles on topics ranging from biogeography to the evolution of behavior to the origins of parasites. Okay, he's written on a lot of stuff. But in The Monkeys Voyage, what we're talking about is how do certain species of animals, specifically monkeys, but we talk about snakes, and even actually we get into some plant life, so trees, how do they show up in different parts of the world? So different countries that are hundreds and thousands of miles apart. How do they do that? So, for example, there's the same species of monkey in Africa as there is in South America. How did they get there? Okay, so you're going to think Continental Drift. No. You're going to think humans did it. Nope, this happened before humans were around. So how does it happen? Well, we're going to answer that in this week's episode. We're also going to talk about how does the same type of tree show up in a tiny island off the Pacific and somewhere else completely across the globe. It's just crazy, and Alan brings it to us. So going to turn it over here to Alan in a second. Guys, head on over to smartpeoplepodcast.com. Connect with us. Sign up for the newsletter. Going to send out some great stuff here soon. Look forward to hearing from you. Hope you enjoy the show. Here it is, Alan de Queiroz. Alan, thank you so much for being on the show. I'm really interested in this topic. It's one that in 150 plus episodes and a ton of books I've never come across. So new territory for me, and I'm sure new territory for many of our listeners. Can you first tell us what is an evolutionary biologist?
Yeah, an evolutionary biologist is just a biologist whose focus is on evolution, right? So the evolution of any kind of organism. Like my specialty for a long time was snakes, and especially garter snakes. So what I was studying was how garter snakes have evolved, their different characteristics, like whether it was feeding behavior or, their color patterns or whatever. But evolutionary biologists in general just study all different aspects of evolution. And some of them, for instance, study anatomy, so the evolution of anatomical traits, but others, and especially these days, probably most evolutionary biologists deal in some way directly with the evolution of genes, or the evolution more generally of DNA, or the changes in DNA that affect or are sort of inherent in the process of evolution.
How does one find themselves focusing on garter snakes? That is, if you're going to focus on snakes, at least look at a cobra or something.
Right. Right. Well, yeah, actually, no, I was going to say that I, wasn't interested in garter snakes originally, although I was interested in snakes from a very early age. Like I was one of these kids who just loved to find snakes. And actually, as it turns out, the very first snake I caught myself and then brought back and kept in a tank was a garter snake. Although at the time I didn't think garter snakes were especially cool. But it turns out that garter snakes are kind of interesting from an evolutionary perspective because there's a whole bunch of them, a whole bunch of species, and they've kind of evolved into doing pretty different things. Like some of them are really aquatic and others are not aquatic at all. They're eating all kinds of different things. And so from an evolutionary standpoint, it's a pretty interesting group to look at.
That makes sense. So they're just a good test case or subject to learn. You weren't solely interested in a garter snake. You were interested in what they do and what they mean for the process of evolution in general.
Yeah. Although I have to say that the way I got into this was really just from being interested in snakes, which I was, like I said, from when I was a little kid. And so that carried through all the way through college. And, when I applied to grad school, I was pretty much thinking I'm going to do something looking at the evolution of reptiles at least. So it really was partly just this, early interest in reptiles and snakes in particular.
I'm always fascinated in these kind of stories just because my own journey, and then I know a bunch of people out there don't really know ever if they're doing what they truly want to do. So you're telling me from 7 to messing with snakes in the yard all the way to present time, you just knew kind of this is my path as long as I'm working somewhere in this field with creatures or something along those lines, then I'm going to be happy.
Well, yeah, I think it's a little more complicated in my case because I'm sort of like at the moment, I'm sort of a non-institutional biologist. So unlike most people who do this. And so in a way, I kind of found that I wasn't that into doing science, like very immersed in an institution. So in that sense, my path was, kind of complicated. But as far as, just the interest in studying animals, yeah, that went back very far.
I'm glad you mentioned that because one question I had, and it's one that I don't think I've really ever asked before, but so you're a non-institutional scientist studying evolution through animals, and we'll get into all that, but obviously a topic that's important in terms of understanding a lot of things about science, but it probably isn't the focus of a lot of people. It's not something in pop culture. Where does funding come from if you're not attached to a research institution?
Yeah, well, in my case, I'm probably more of a writer at this point than a research scientist, but I do research still.
Okay.
And kind of in a way, I do it like sort of parasitically, like, I team up with people who have grants from NSF or whatever, and collaborate with them to do things.
That's great. Yeah, that makes a lot of sense.
I've even as a non-institutional person, well, I shouldn't say I'm non-institutional because I do have an affiliation with the University of Nevada. And I can apply for grants through the university. But, I've also got a few years ago, I got a grant from National Geographic to do some stuff. So, there are potentially sources of funding.
Very cool. And now I was reading, as I was looking over your book and reading some things, I came across the term for the first time, biogeography. What does that mean?
Yeah. So biogeography, it's pretty much what it sounds like. So it's the study of the geography of living things. So it's basically the study of why things live where they do. And so thinking about particular groups, like why are there monkeys living in South America and Africa and Asia? And why are they not in, at least at the present time, in the United States or Europe, or although actually I shouldn't say Europe, there are monkeys in Europe, but like Northern Europe, why are they not there? So it's questions like that, like just why are particular groups found where they are?
Okay, yeah. And I never knew the term. Obviously, the idea behind it is what you wrote about in your book. And I really want to cover that because it's a fascinating thought. It's one of those mind-bending things that I have never really given any thought to. And then once I looked at your book, and the book is The Monkeys Voyage, How Improbable Journeys Shape the History of Life. And then I just thought, what you just mentioned, wow, there's monkeys all across the world, similar species, but they can't obviously get there now. how did that happen? And that's what your whole book is pretty much based on, right?
Right. Yeah. I mean, it's kind of I think it is something that, even a lot of biologists don't think about it very much. In fact, a friend of mine that makes this joke that, I think it's some other biologist made a joke about, well, everything's got to live somewhere, so it's not really interesting. But I think it actually is really interesting when you think about these cases that just seem weird, like some mammal or frog or something that's living on an island that was never connected to the mainland. So, it's kind of a paradox, like how did that thing get out there? And, there are all kinds of questions like that in biogeography.
Well, that is where we are going to go. I'm interested to know the answer to some of that because obviously I think this is fairly common amongst people who don't know this subject, but I just assumed the idea of continental drift, that one time there was this one big landmass and everything lived on it. And then as it broke up, things just kind of stayed there. According to you, there's a lot of fallacies in that thought process, right?
Well, yeah. So, I mean, clearly continental drift occurs. I mean, continental drift is a fact. And clearly also it's, has been important in sort of producing the distributions of organisms that we now see. So, there were these groups that lived, for instance, on this southern supercontinent of Gondwana. And when that supercontinent broke up, different members of those groups were separated on the fragments of that giant continent. So that kind of thing is clearly true. But the question is, if we look at the world today, or the kind of the focus of the book is, if you look at where things are today, and you look at these cases where, there's some group like monkeys in South America, and then they have relatives like the monkeys in Africa. The question is, how often are those kinds of weird cases due to continental drift versus something else? And that's where kind of, so for a while, I think people were so excited about this explanation of continental drift that they kind of, at least some of them kind of got carried away and just felt like, oh, this explains all of these weird distributions, at least the ones, that you could possibly explain with continental drift. And that's where they kind of went astray, which, they started thinking that, for instance, ocean crossings like monkeys crossing the Atlantic are just ridiculous or so rare that you don't even really have to consider them as explanations.
Can monkeys really cross the Atlantic?
Well, I guess I wouldn't say for sure they did, but it's certainly looking like that's the best explanation for why you see that distribution of, monkeys in South America and Africa.
How much do we know about human? I mean, I guess we, considering in the history of the world, we're a fairly small blip on the radar, but how much of it is humans' impact on bringing different species around as they traveled?
Yeah, well, that's something I don't actually touch on much in the book.
Okay.
The book is mostly about natural sort of ocean crossings. So like those monkeys, they got to South America many millions of years ago. So clearly, humans didn't bring them over there.
Right.
But, in a lot of cases where, it's not very clear when something arrived in a place, then you often do have to consider the possibility that humans brought them. In fact, the case that I start the book with, the garter snake case, where there's these garter snakes on Baja, California, and they also, like, the rest of the species is kind of on the main part of Mexico across Cortez. So that case, I mean, again, in the study that we did on this, we came down on the side that they crossed the Sea of Cortez on their own. And, I'm willing to bet that that's probably the right answer. But in that case, there's at least a remote possibility that humans could have actually brought them across the Sea of Cortez.
Right.
And in other cases, it's even, well, in other cases, it's pretty clear. In many cases, it's very clear that humans did transport things to various places.
What's one of the most odd examples that when scientists, or I guess biologists, look at it, they just go, I don't know. I don't know what it is. Like opposite ends of the world, same species, can't fly, can't swim. Just give me an example of something like that.
Yeah, well, I mean, the monkeys is obviously, that's kind of the main example in the book.
Yeah.
So, just the fact that it looks like monkeys cross the Atlantic. And I think most biogeographers believe that now, just because all of the evidence kind of points to that or refutes other possibilities. But there are a whole bunch of other cases. Like actually, there's been one that was kind of in the news a little while ago, which was there's this tree in Hawaii called a koa, and its closest relative is, or actually, it was something that was considered part of the same species, lives on an island in the Indian Ocean. It's almost on the opposite side of the world from Hawaii. But it looks like the only reasonable explanation is that somehow that Hawaiian tree, or maybe it was only a seed or something, but somehow it got across, it went halfway around the world and ended up on this island in the Indian Ocean. Even though that tree really, it's not designed for doing that. It doesn't have seeds that are meant to float on the water or anything like that. So that's a pretty bizarre case. And actually that's one that came out after the book did. So it's not actually in the book.
All right. Well, you've got the research, you've got the grant money. What happened?
Well, yeah. So in that case, I mean, it's one where, this team of people who were studying it, they looked at it, especially, I mean, most of these studies now are using DNA. So, they looked at a bunch of DNA sequences for these trees in the Indian Ocean and the ones in Hawaii. And it's just really clear that they're each other's closest relatives, and that, the ones from the Indian Ocean basically evolved out of the Hawaiian one. So yeah, just based on the genetic, difference, or the extreme genetic similarity, it's pretty clear that that's the case. And there's really, so then you've got these two things on opposite sides of the world. And it's pretty clear that they weren't brought there by humans. So really the only explanation is that, somehow they dispersed naturally. Because those land masses, Hawaii and this island in the Indian Ocean, there's no possible way that they were ever connected, at least not, ever actually. So,
but we don't know how that happened. Is that what you're saying? How those seeds and essentially those trees ended up in the places they did?
Well, yeah. So that's another, I mean, in a way, sort of probably what keeps some people from believing these things is that for the most part, we don't know how these things happen. So people have conjectured in that case that maybe a seed or something got stuck onto a seabird, and, the seabirds do fly enormous distances. Mm. And so, maybe that was the way it happened, but, we'll probably never know that. I'm sure we'll never know that for sure unless somebody built a time machine.
I can buy that argument though. That sounds pretty good. Now, what about, I think I might have skipped over it because I read some things in your book and just in different articles, but if there was at one point this one landmass that then split up to the world we know today, why couldn't, say, the monkeys have just been on this one landmass, and then when it split up, they ended up on these different ones, as opposed to what you posit, the natural ocean crossings?
Yeah, well, so and it basically comes down to the evidence. So yeah, it's definitely a plausible sort of hypothesis that it was from, these organisms just being carried with the landmass as it broke into pieces, right? So you could call that the kind of fragmentation explanation or fragmentation hypothesis. And the reason then most cases that we don't think that happened, I should say that probably does explain a lot of cases. So, I don't want to say that everything's, about ocean crossing.
Sure.
It clearly isn't. But in a lot of these cases, it's pretty clear that these organisms or species on these different land masses, like that they separated in an evolutionary sense. They branched from each other way too recently for it to be because of the fragmentation of land masses. Mm. So, for instance, in the case of the monkeys in South America and Africa, from looking at the similarities in their DNA, it looks like they split from each other on the order of 40 million years ago, kind of give or take 10 million years. Mm-hmm. But, and that sounds like a long time ago, but it's not nearly long enough to be explained by the separation of Africa from South America. So that's really the critical kind of evidence that's come to light in recent years, that, there's all this DNA evidence that shows that a lot of these sort of evolutionary separations are too recent to be explained by the land masses breaking up and carrying things with them.
We'll be right back to this interview after a quick word from our sponsors. Online platforms are sparking one-to-one connections faster than ever, and we're in the middle of a quiet revolution that's turning everyone into a savvy contractor. Need some cash and have an extra bedroom? Let Airbnb play matchmaker. Hate getting rejected by taxis? Let Uber pick you up. You might even get some valuable business advice along the way. You never know what day job that driver may have after all. My favorite matchmaker is 99 Designs. The platform connects creative entrepreneurs and designers through a contest model that's a lot like a dating service. And oh man, we here at Smart People Podcast have had some great design matches on the site. It starts with the highly anticipated speed dating round where dozens of designers submit ideas based on the creative brief. If a connection is sparked, clients invite designers to the next stage in the relationship. In the final round, the two sides find out whether it's true love or fleeting admiration. The happily ever after, you'll get a design that's perfect and the designer scores the prize money. You get to be involved in the process and walk away with a logo, website, or other design that truly represents your brand. What if you could start your next design project today, make that connection and have dozens of designs to choose from in just 7 days? Well, now you can. Visit 99designs.com/smart and get a $99 power pack of services free.
One of our sponsors this week is Personal Capital. Personal Capital is an awesome tool that helps you solve the problem of having too much information when it comes to your finances. So you know that with your 401ks and your IRAs and Roth IRAs and different A's, that there's just information everywhere. You have different accounts, different passwords, different charts and graphs and things to keep up on. And the biggest thing is, oftentimes you're paying for somebody to be managing all of those different funds and accounts, and you're paying too much. So what Personal Capital does is it keeps all of these accounts together, organized on one screen on your computer, phone, or tablet. And it also has real-time intuitive graphs. So in one quick snapshot, you can get an idea of everything that's going on in your finances. It also shows you how much you're overpaying in all those capital management fees, and then how you can reduce them. So it's a service that actually makes you money. And it also makes you stay up to date on your finances, which, let's be honest, we all need to do a better job of. And the best part of all is it is free. To set up your free account, go to personalcapital.com/smartpeople. Again, make sure that you go to /smartpeople because that helps us out and lets them know you heard it here. So remember, you have to go to personalcapital.com/smartpeople and set up your free account today. Watch your money grow, lower your fees, make it easy on you.
Yeah, and I read that and I was just fascinated by it because that does make a lot of sense. And as you explain in the book, it really threw a lot of people for a loop a little bit because it was kind of easy to just hang your hat on that and say, all right, good, we can move on. And now having to rethink their previous hypothesis, I'd imagine it had a couple people confused, a couple people upset, and it's back to the drawing board.
Yeah, well, for a lot of people, and I mean, I wouldn't really, I sort of include myself in this group because when I was in graduate school, I heard about this Continental Drift explanation for these, kind of fragmented distributions. And, I thought, oh, that's really cool, and in fact, when I taught an evolution course, it was probably like the late 90s, that was when I talked about biogeography, that was the hypothesis that I really focused on. And, partly it's this very seductive hypothesis, it kind of, oh, cool, the continents drifting apart. They just explain all these things. And, it's kind of like also that they explain all these the distributions of all these different groups at once, so not just monkeys, but like tree frogs and lungfish and, southern beech trees, all these different things. So it's very seductive because, it's kind of simple, but it's also really general. And, that's something that scientists love, a simple, general explanation. So people were really taken by that. And, a lot of them had to be kind of forced into this other view. And what forced them was the evidence, this DNA evidence for the most part. But I think now probably, most people who study biogeography have been pulled to this other view where they're at least thinking that, it's not all continental drift. There's these ocean crossings and other kind of long distance events like that are really important too.
So, I can almost hear people asking, and I had this question as well, ocean crossing. I mean, come on, you're like, okay, is a monkey swimming? That's not
Right.
happening. And one of the really interesting kind of, I don't know if it's considered a hypothesis, I guess it has to be, is a land raft. And so I was hoping you could kind of talk about that and some of the other things you've figured out might be the cause of these ocean crossings.
Yeah, well, so in the case of monkeys, I mean, really, the only sort of reasonable idea is that they rafted across the ocean. I mean, a monkey's not going to get stuck to a bird and go across the ocean. It's not going to be blown by a storm in the air all the way across the ocean. So rafting is probably the only reasonable explanation for monkeys and other, sort of reasonable sized animals, let's say. And the thing is, there's actually a lot of evidence that these rafts form really often. Like one of the things that happens is you get pieces of the banks of rivers breaking off and, going down to the sea and then just, drifting out into the ocean. And in some places, the currents are such that those things, if they're big enough so that they're not just going to get broken up pretty quickly, that they can go for hundreds or even thousands of miles being pushed by the current. So it sounds on the face of it like a ridiculous kind of explanation, but then when you look at, the actual formation of these things, you find, these things are actually forming pretty often. And then when you think about how long, we're talking about, like in the monkey case, that seems to have happened, at least the Atlantic crossing, just once in, say, 40 million years. So that's kind of a long time. It's a lot of potential rafts going out there. So, most of them aren't going to have monkeys. And even if they do, most of them are not going to make it. But it only takes one, so to speak.
Well, I think that what you just mentioned there is a perfect segue into something we were kind of discussing prior to when I hit the record button. And that's just the idea of how fickle evolution is in general, or I guess evolutionary history is the phrase you used. And we kind of touched on it real quick, but I'd love to talk about that a little more because, again, not something I've thought about too much. I mean, granted, I think the miracle of life, but talking about something like 1 in a million or 40 million land rafts, which is what got a monkey somewhere, really puts things in perspective.
Yeah, well, I think like one of the interesting things to me about this subject of the ocean crossings is that, it provides all these really compelling examples of just how fluky evolutionary history is. So, I mean, I think a lot of people, like people who study evolution, I think most of us believe that evolution is very random, and not just at the level of mutations are random, but, these bigger events in the history of life are kind of chance events. But it's actually kind of hard to point to an event like that. Like, for instance, I bring up this in the book that Stephen Jay Gould, who's, really was a really well-known evolutionary biologist, he pointed to this creature called Pikaia, which lived way back in the Cambrian and might have been the ancestor of us, like of the whole vertebrate group. And so he gave this example of, if Pikaia hadn't survived, then, maybe there wouldn't be any vertebrates at all. So obviously there wouldn't be humans. And so he pointed to that as kind of a chance event that changed everything. But, I kind of thought about that. And I think a lot of other people who read that book sort of had the same thought that, I kind of believe the general idea, but I don't know about this Pikaia example because we really have no idea why it survived or didn't survive. Like, it might have been sort of, it might have had some pretty special qualities that meant it was definitely going to survive, right? So the difference with these ocean crossings is, like if you think about the monkeys crossing the Atlantic, it's like, I think most people would agree that, wow, that's a really random event. That's something like, if to use Gould's own metaphor, which I think is like a really appropriate metaphor, if you replay the tape of life, probably in this next, in the next replay, if you started from before, when monkeys crossed the ocean, probably in this subsequent replay, they wouldn't make it at all. Like maybe something else would, but it's such a random event that it's probably not going to happen if you sort of reran evolution. And you can say that for a lot of these really weird ocean crossing cases, that they just seem so unlikely that they're things that maybe are really one-time events. And if you replayed history, they really wouldn't happen again.
Do you think that, as I think about all the fluky things through our evolutionary history that have occurred, oftentimes I feel like it's almost easy to be like, well, because it's so many millions and millions of years, anything could happen. Do you think that sometimes we might fall back on the fact that although we can't explain things, because it's been so long, the chances of one thing happening are pretty good?
Yeah, well, I think, there is a danger of that. I guess that what I see as kind of, a critical thing in this case of the ocean crossings is that, like, for instance, I wouldn't use that as kind of my main argument for saying that, something like that monkeys crossed the Atlantic from Africa to South America. So it's more like you have this other evidence, which is in this case is like DNA and fossil evidence that pretty clearly suggests that that's what happened, or at least it makes it very likely that that's what happened. So then it's kind of like, it's kind of more like then you have to kind of accept this idea of, oh, well, these things that are very unlikely, say in any given year, given a long enough time, they can happen. But it's not that you use that argument as the primary argument. It's more like that's something that becomes part of it when there's other evidence that indicates, that something had to cross an ocean.
Right.
That makes sense. But
it definitely does. I mean, and if it was a little more easy to figure out, then you'd have to be studying something else, right? I mean, that's the purpose of why we have smart people looking into what's going on.
Right. Well, yeah, certainly partly what makes it interesting is that, often it isn't that easy to figure out.
Yeah. And what do you think is in your mind, the benefit of studying this, understanding these types of things, taking these different hypotheses and testing them and really trying to understand our evolutionary history?
Well, I think, sort of at the most basic level, it's just, people are interested. I think, most people anyway, are kind of interested in how the world got to be the way that it is. And so, there's an infinite number of different answers to that. And some of them are kind of trivial or, are not affecting things in a very striking way. But I think that in this case, these ocean crossings, they really have, if I and other people are right about this, then these ocean crossings have changed the world in, just a tremendous way. Like there's so many of them and they've had, such huge effects on what kinds of organisms live in different places that, it's a huge part of what makes the world the way it is today.
So would you say, if we were to sum it up from your work, that ocean crossings are the most important aspect of how animals and life have spread out across our world? Is that the primary means?
Yeah, I definitely wouldn't say that because, I think that, for example, in the case of South America, one of the big things that happened to South America was, about 3 million years ago or so, it got connected by the emergence of the Isthmus of Panama. It got connected to North America. And then all these different animals and plants and other fungi or whatever were then able to move between those two continents pretty easily. And that obviously had a huge effect, especially on, the biota of South America, but also on North America. And so that kind of thing has happened throughout the history of life too. So I definitely wouldn't say that these ocean crossings are the most important thing, but I would say that they are like hugely significant. And that's a change from what at least a lot of people thought, say 20 years ago, when people were more focused on this idea of continental drift.
Oh, wow. I didn't realize I didn't realize it was that recent, within the past couple decades.
Well, yeah. So, I mean, the history is kind of complicated, but, so there are some people who have kind of persistently believed that these ocean crossings were important. But a lot of people got sort of seduced by this idea of continental drift as, kind of incredibly dominant, as sort of the thing that explains like the huge majority of these cases. So for a lot of those people, it's only been in like the last 20 years that they've changed their minds. But on the other hand, this idea of ocean crossings, I mean, it goes way back, so even within evolutionary thinking, it goes back to Darwin, who was a great believer in, these kinds of events, these ocean crossing events. But so it's only this kind of in this recent history where people got, in a way, sort of seduced by continental drift, that then there's been this more recent shift to, again, thinking about ocean crossings.
Very interesting. Well, this is great stuff. It's something that opened my eyes to a topic, as I mentioned, that I've never really thought about, but it's just a great way to expand the mind, a thought exercise, a way to understand our world, and really fascinating stuff. Again, your book, The Monkeys Voyage, How Improbable Journeys Shape the History of Life. I found it, it was ranking high on Amazon. I love it. People out there are enjoying it and rating it really highly. I want to say thank you for being on the show, and also you mentioned how you're doing a lot of writing these days. Where can people go and keep up with what you're studying and the things you're uncovering and really follow along with what's going on?
Well, probably the main place is I have a blog, so it's, I'm trying to remember. I think it's Monkeys Voyage or monkeysvoyage.wordpress.com, something like that.
You don't even know your own blog?
Yeah. If you put in Monkeys Voyage and WordPress, it'll come up.
I think it's, let me see, I just looked it up. I think it's just the monkeysvoyage.com will get you there.
Oh, well, yeah, that's the publisher's
okay.
Site.
Okay.
So the WordPress site is the one that where I actually have a lot of writing on there about biogeography, but about other things that are more or less related to biogeography. Some of them not related at all, actually.
And we'll go ahead and link to both of those. So if anybody wants to check it out on smartpeoplepodcast.com and just go to this episode, and we'll put a link up there. Well, okay. Alan, thank you so much for being on. I really appreciate it. Great book. I'm going to keep up with your blog and see how much more you can learn about the world and how it's forming and how it formed in the past. I really appreciate it.
Okay. Yeah. Thanks a lot for having me.
All right. Have a great night.
Okay. You too.
All righty. Bye-bye.
Welcome back. I hope you guys enjoyed that fantastic interview. If you enjoyed that show or any of the other episodes that we've done, please head over to iTunes or Stitcher and leave us a rating and review there. It really helps out the show. And if you ever need to reach out to Chris or I, you can reach us at our email address, smartpeoplepodcast@gmail.com. You can send us a message on Facebook at facebook.com/smartpeoplepodcast, or you can hit us up on Twitter at smartpeoplepod. As Chris mentioned at the beginning of the show, we do have Smart People Podcast stickers, so if you want one of those for your friends and family, just drop us a line on one of our bajillion ways of contacting us and let us know. We'll get those stickers out to you, and you can start putting those all over the city or on your laptops, whatever you guys want to do that. We'd appreciate you getting the word out there and using those stickers. Don't forget to check out our fantastic sponsors, 99 Designs and Personal Capital, and we will see you guys next week.